Now here the intuition is slightly subtler. The reason why my utility fluctuates is that there is one thing which is kept constant, but it's not my utility. It's my marginal utility of non-economic. Because if you work out the prediction of efficient insurance, the one thing that should remain constant is the marginal utility of non-economic. Why that? Because the way you check efficiency is something like we cannot sign a contract whereby in some state of the world I give you $1 and in other states of the world you give me lambda dollars. We cannot find a lambda such that this kind of transfer is mutually beneficial. Well, this kind of transfer cannot be mutually beneficial if there is no fluctuation in my marginal utility. But the point is, since utility of income is a nonlinear function of income, the fact that marginal utility of income is constant does not imply that the absolute utility of income is constant. Actually, it does vary. Remember that both the W and the transfer received vary. So yeah, so this is simply to say that in addition to everything, the way we think in terms of insurance against wage risk is quite different from the way we might think about insurance against income risk, because we have to take into account behavioral responses, and the behavioral responses introduce things that may not be completely intuitive to start with. Well, let me just continue. Well, no, there are application to Cobb-Douglas preference. You can actually, what we do in the paper is we have a full-fledged model. We write it down. You can compute everything under the assumption of efficient resharing. Everything is identifiable. You can take that to data and so on and so forth. I will not show you the result of the estimation because, as I said, but let me just go to data and implementation. So the data, we have 16 villages. Within each village, we have 21 to 40 households. So we have 150 or 200 people. We have almost 90 observations. It's comprehensive. It's incredible. We know everything. We know whenever one of those households is selling a bullock or buying some kind of fertilizer, we know that. We have all those data. And these are the kind of things that we're doing. First of all, identical risk aversion is strongly rejected. The fact that you take into account labor supply doesn't change. If anything, it reinforces the fact that people have different risk aversion. What about efficient resharing? Here we can do the test in a clean way. We can control for the income process and control and test whether income realization have an impact. What we find is that in half the villages, actually a bit more than half the villages, efficient resharing is not rejected. Let me show you the data. So these are the various villages. Each of them have an ID. This is the number of households. Now, it's a random sample within each village. It's not that there are only 41 households in the village, but it's a random sample of 41. And that's the probability under the null, the probability of observing what we observe under the null that there is efficient resharing. And what you can say is that in a bunch of those households here, it's not rejected. There is one in which it's rejected at 10 but not at 5, and then you got 1, 2, 3, 4, 5 in which it's rejected. When it's rejected, it's very strongly rejected. But see the assumption, when we have very good data, it's not that the data are imprecise or we only observe them once, so there is a lot of noise. We have very precise data. Still, in about more than 50% of the cases, we do not reject efficient resharing. And when we do now, it's still interesting to ask yourself what happens in those cases in which it's rejected. And that's the current direction in which we're going. And here, let me just mention 3 possible explanations that might account for the fact that in some cases we reject efficient resharing. The first one is there is actually resharing, but not at the village level. It's a smaller level, which should be something like the network. So can we identify networks? And most of the time we can. Well, not perfectly, but we can identify family networks, for instance, or family relationships. So one thing we can do is we take one case in which it's rejected, this one, for instance, and then we split those 31 households into networks. Now, of course, since it's the sample, it might be that a person, a household in this village belongs to a network, but is the only person, the only member of this network within the sample, in which case we cannot do anything. So we have to only keep those households for which we have at least 4 or 5 people belonging to the same network within our cell. Now, if you do that, what you find is you got a group of 3 people in the same network, another 3 people in the same network, and another 7 people in the same network. The beauty of those tests is you don't need to observe everyone in the network to test efficient resharing, because if it's true at the network level, it's true at any sub-level. So you can do the kind of test, and what you see is that it's not rejected within the sub-network. What's rejected is the fact that those networks don't seem to do a very good job sharing risk between them. So that's one possible explanation. If it's rejected, it might be that there is resharing, but the village is too large collectivity. We should do a smaller collectivity. There are 2 other things, and we're currently working on this. One are commandment issues, and there is a bunch of very interesting work in the literature, and the theoretical literature. So those are situations in which there is, if I have a risk-sharing agreement, it means that in some case you will have to pay me. But of course, you're willing to sign this agreement ex ante because it also means that in some case I will have to pay you. But if I am the only lucky one and you have to give me the money, you might be reluctant. Actually, so the question is, how can we enforce? And all the literature, all the arguments I showed you were implicitly assuming that we had full enforcement, that enforcement was not an issue. But in practice, enforcement is an issue. What happens if we cannot enforce? The only enforcement mechanism is if you do not honor your word by paying me, then you're out of the resharing device for the future. What are the efficient contracts under this constraint? We know that from the theoretical literature. So there is an open question, which is how can you test that, take that to data and hear some ideas. And the final thing is asymmetric information, which is very much one limitation. Okay, I'm done. Let me just conclude. We have a technology. You can do much better than the standard test. You can allow for heterogeneous risk aversion. You can take into account the transfer allocation, including allocation of risk. You can model wage uncertainty, and you need to develop specific tools, and you can explicitly model responses in terms of labor supply to both income and wage shocks, and they are different. The point is you need panels. If you don't have panels, my philosophy now is if you don't have long panels, testing for efficient resharing really requires very heroic assumption that I'm a bit reluctant to do. Of course, I'm spoiled because I have gross data, and I can afford to have some contempt to short panel data. And these are a bunch of responses. I'm done.